Hello, everybody. This is yet another Evernym sprint demo. This one's actually a sprint demo. The last couple have been more of a project conversation. Today we've got some good progress to share. We've been working hard at work over the last few months on the verifiable credentials approach to provide what we call it the rich schemas project. Provide encodings, mappings, proof presentations, all that on the ledger. We're going to talk about that more today and be able to show some parts. We've also been working on Aries shared libraries alongside our friends that used to work at the Sovrin Foundation and with the team at British Columbia. The indy-vdr verifiable data registry, the Aries credential library, the Indy credential library. We've been helping build out those libraries and putting rich schemas there. And that work has finally gotten mature enough that we're excited to show it. We've also been working for a long time now, 8 months or something, to adopt the Aries interop profile version 1 and really meaningfully adopt it so that we can show interoperability in practice. And previously we've shown demos with Akapi, the Aries Cloud Agent Python, and today we're going to show a demo with Cred. But we've also passed the protocol test suite with the libvcx library, and that's going all the way. That libvcx is going into Evernym products over the next couple of weeks. So our customers are going to be able to have this interoperability in the wild fairly soon. We're excited for that. So that's the main goal for today, the main set of goals. Looking at the backlog, you can see rich schemas work has taken most of our time. I mentioned this previously, but we have a statically linked ZMQ connection client tool that's available as well. We have talked for a long time. We support indy-node supports Ubuntu 16.04, which has been fine because that's where the stewards are running. That's losing support from Upstream fairly soon, and Ubuntu 20.04 is coming out. We've talked for a long time about supporting 18.04. We renamed the epic. We're just going to skip that and go straight to 20.04. We haven't renamed all the issues yet, but we're going to start picking that up. That's been worked on in the past by various contributors, and we're going to take and finish that work up. And but really, that's the main focus on indy-node. As we mentioned before, indy-node, our development on indy-node is slowing as we focus more on the Aries tier and some of the big features we want to add to Aries soon. And so, well, we want to add to Indy and Aries, but it's more the Indy SDK tier. And so we'll probably release less often on the indy-node side. Instead of monthly releases, we'll be looking at every other month. We did not release February. We were going to release in March, but there's an upgrade to Ursa that we think will be good to incorporate into the next release. So we'll wait a few more weeks and put an Indy release out in April. And then we'll try and keep a every other month cadence from that point forward, depending on what needs to be released. But at this point, we've got most of the rich schema stuff in. We'll have the upgrade to Ursa. Hopefully we can get the Ubuntu 20.04 support into the April release. And then we won't really need a new Indy release unless we find a bug or something. We haven't found any in a while, any impactful ones. We won't need another release until the Anon Creds 2.0, the new approach to revocation, is ready. So don't know how long that'll take, but we hope to get that out in a few months. So that's the plans on indy-node side. On the Indy SDK side, you can see a similar focus that we've been very busy with rich schemas work, with integrating the indy-vdr. We want to, the current thinking, the plan is to take libindy and split it into a variety of libraries. Some are Aries libraries, some are Indy libraries. But then we want to call all those libraries from libindy so that we can keep using it, stay backwards compatible, and so that everybody that consumes libindy can consume these new libraries with no changes. And also so that we can go through the testing the libindy's been through and validate that everything still works as expected. And so that's what we've been doing here. You can see that we've done a POC of the VDR inside of libindy. We've been working on playing with the rich schema stuff in the new Cred libraries. So we made a lot of progress there. the next round of stuff, currently, we're going to continue the rich schemas work, but currently we teed up all the anon creds work so we can get a size and idea of how much effort that's going to be. Probably going to take a quarter for our team. This is a pretty rough estimate. But yeah, by the end of Q2, by June-ish of 2020, we'd like to have anon creds getting pretty mature in both indy-node and in the Aries libraries so that we can start to build on it. Now, we're only going to achieve that if we get some help. If your team has been contributing to Aries and to Indy, then please work with us and we can help you understand how to participate in getting that new approach to revocation into the product, into Indy and Aries so that your products can build upon it. So that's the call for help we want to do. That is really where we're at. So now I'm going to stop sharing my screen and we'll let Alex and Andrew Nikitin take us through the rich schemas stuff, and then we'll talk about street cred. Oh, I should ask before we do that. So we're not doing an Indy node release right now. What's the status of the Indy SDK release, Sergey?
Well, actually, we have this candidate approved by QA, and I think some artifacts already moved from RC to stable. But as far as I know, there's some problem with PIPE, so at least Python artifacts are in progress now, and probably they are a bit blocked by third party here. But in general, it's ready and RC approved to be stable. So just a question of time and availability of external resources.
Excellent, thank you for that. And the main goal of this release is the Aries compatibility stuff. The goal was to get it out at the end of February. We are about a month late, but it allowed us to do additional testing, as you'll see in our demo in a minute. Fixed a bunch of stuff with that compatibility, so we thought that was a good trade-off. The other call for help that I need to put out is that currently all our pipelines are based on Jenkins, and Jenkins is rickety. Our Jenkins usage is rickety. It's not really well understood by people that aren't on our team. And Hyperledger as a whole is moving towards GitHub Actions in Azure, and we're not going to be able to complete the work around revocation that we'd like to do and that we know other people would like us to do if we don't get some help on getting the new libraries all ready for GitHub Actions. That's a really nice project for somebody who's new to Indy to pick up, because it gives you a good understanding of the code base, but you don't have to have a really deep understanding to be productive. So again, if that's something people are interested in helping with, please reach out to us on Rocket Chat. So I'm going to stop sharing my screen and let Alex take over.
Okay, thank you. Well, so the first part of my demo is devoted to the updates we have in Indy HIPE, and this is the HIPEs related to rich schema. In general, we can say that we finished design and HIPEs around the common part shared for all rich schema objects, and also we have HIPEs for rich schema itself, for context, encoding, mapping, and credential definition. So this part is done. Also, we have already implemented this in indy-node, and we already have implementation in indy-vdr that Andrew will show us. So rich schema object common is the first HIPE, which is maybe the main point of interest here, since it provides a describes a general logic, how rich schema are related to each other, how they're identified. Some examples, common templates, common examples apply to any rich schema object, because actually we defined the common template, and the only difference between rich schema objects is a content field and the specific validation, specific rules what the content field contains. And all metadata, all identification, how rich schema is stored in indy-node state, it's all the same. So that's why this HIPE provides this content. And individual rich schema HIPEs, they are just about the specific applied to this particular rich schema object. For example, for context, it must have a add context field. And here we're just describing how the transaction, in the transaction to store it on the ledger, how it looks like. The same for rich schema. By the way, both context and rich schema hypes, they already existed in indy-hype repository, and we've just updated them to follow to match the common functionality, the common logic. So here you can see the description of fields we expect in rich schema itself. And the general, this is supposed to be a JSON LD with add ID, add type, add context, and with a graph of the claims, claim attribute names. Also, we have encoding objects. This is they're needed to make sure that we have described the algorithm, how we transfer the raw claim values to integer ones as required by Kamenisch-Lisianskaya ZKP signature scheme. This is specific to how indy credentials are done, the math behind this, and it describes the format of this encoding object, what are the fields there, and what are the validation there. Then we also have the mapping object. This one is needed to actually map the claim attributes to encodings. So we have a schema with a number of attributes. We can say that we would like to maybe use just subset of the schema attributes for our claims. And then we map every attribute to the corresponding encoding. And also for our Kamenisch-Lisianskaya signature scheme, we need to make sure that we have an ordered rank of, an ordered list of these attributes. So we specify this order explicitly. And also we have a credential definition object. It's pretty similar to the current credential definition in non-rich schema approach. Yeah, so the only main difference that it have a reference to the new mapping object. It has a reference to the new mapping object. And also we implemented a HIPE for the credential format itself. It's not merged yet, but I believe it will be merged pretty soon. And the main thing here that in general we are following the W3C verifiable credential data model 1, which became an official recommendation now. So we are going to be fully compatible with this specification, but in the credential they have a number of explicit requirements for how these anonymous their knowledge proof credentials related to this specific. So here we have the properties that are required, that must have for any credential. Again, all these properties are taken from the specification, W3C specification. We just making sure how Indy is going to use them. For example, the type property, it's always a list of 2 elements. The first element is a verifiable credential type, which is common for all W3C verifiable credentials. And the second one is actually the ID of the corresponding rich schema, which we are going to use in the scope of Indy. And credential schema, well, although the name of this attribute is credential schema, actually it must point to the corresponding credential definition. That is the entity containing the public keys, which can be used for verification of the signature of the proof. Yeah, so also we have a number of assumptions. Again, they're not against the specification, but we're just making them more explicit than they are in the specification. And one of the core assumptions that we assume that any credential must be issued, again, one and only one schema, and hence one and only one mapping and credential definition. Okay, so also we have a relationship diagram about this verifiable credential, and that it uses a single rich schema, single credential definition, and so on. And we have some examples for a given rich schema, for the given mapping, for the given credential definition. This is how the credential may look like. So again, all this all these fields, properties like context type, credential schema, issuer, issuance dense, credential subject, proof, they're compatible with W3C. This is a must-have field from W3C specification. But here we're just providing a real example how it may look for our Kamenisch-Lysyánskaya signature scheme. And also we are talking about where it needs to be implemented and raise a question about compatibility. In general, we are not going to make it compatible with the old non-W3C and old non-rich schema approaches, but some applications built on top of libindy may have assumptions regarding compatibility and implemented. Okay, so that was all about the HIPEs. So as a summary, we finished the HIPEs about individual rich schema objects, and we have a HIPE about verifiable credentials itself. And now let me show about what we have from implementation point of view. And as I said, we finished implementation of rich schema objects on indy-node side. For this implementation, we were following our pluggable request handlers approach. So you can see we added a number of new request handlers for every rich schema object. There is a base class, since all rich schema objects, they share the implementation, how it's stored in the state, for example, and some other generic things. But every request handler for every specific rich schema object, for example, for rich schema encoding, they have may have some specific static validation and dynamic validation rules. And just to remind, static validation are the rules around the general format, which is not dependent on the current state. And dynamic validation are some rules dependent on the current state. For example, in credential definition, in the scope of dynamic validation, we are checking that the referenced schema and mapping are present on the ledger, and yeah, this is really a mapping object and not anything else. Okay, so we have tests for this. We have tests for these request handlers. Following the general unit tests template, there's a bunch of tests for common logic, how it's stored in the state, and some validation specific for average schema objects. And also we have some integration tests that all things work together. On indy-node side, the sets are currently not using SDK yet, but once we fully finish the support in SDK, we can replace these calls with a real SDK one. But we already have a good progress there, and Andrew is going to show you that we already have implementation of these calls in indy-vdr, and we have integration tests on indy-vdr side, which are working with the real ledger. They can send requests and get replies for all rich schema objects. So Andrew, please continue.
Hello everyone. Let me share my screen. Let me share. Okay. Can you see my idea? I hope yes.
Yeah, let's
Yes,
go.
Okay. Okay. During the sprint, I was working on rich schema objects implementation on indy-vdr side. Firstly, okay, what was done? Firstly, I implemented all of internal rich schema structs, like general rich schema. It is used for write requests, and also implemented a lot of structs for all of rich schema objects. For now, implemented structure for types, for all types of for all now possible types of rich schema, and also was implemented to read requests to read request object by ID and by metadata. Also was implemented builders function for building all kind of rich schema object for write requests, and for read request too, by ID also and by metadata. Then was implemented external API calls for wrappers, for example, also for rich schema, for write requests regarding rich schema stuff, and for get request too. And on indy-vdr now has only wrapper for Python, and I implemented corresponding function for Python wrapper. Then was created a bunch of integration tests. Wait, sorry, I will run this. This integration test check that all builders works fine. Also, as Alex told previously, I get as example all of contents for all our rich schema object, and implemented a chain of rich schema object sending, like schema, context, encoding, map, mapping, credential definition, and presentation definition too. Also, what else? Also was implemented, also was changed GitHub Actions on the indy-vdr side for running implemented integration test with a real indy-node pool. I took Docker file from indy-vdr side and integrated it to GitHub Actions, and now all of PRs will run. All of PRs will run the integration test too, and my implemented integration test too. Well, I think that's all from my side.
That's great. It's exciting to see. Every time we go through this process of working on a project for months on end, and then we finally get to a point where we can show code in practice, tests that are passing, and soon we'll be able to show real world usage. Very cool. Thank you, Andrew. Now, Artem is going to show us some interoperability stuff.
Yeah, and while Artem is sharing his screen, just wanted to mention just explicitly that for each schema object, we have a very generic API, just 3 calls to write and read any rich schema object. So you can just specify the type, rich schema type there, and all other stuff, it's kind of the same for the people who would like to use it. Yeah.
Thank you, Alex.
Well, regarding my demo, I have prepared a video, but I just recognized a couple minutes ago that I don't know how to share a screen with video and sound from a PC.
Oh, Alex already got it.
Hello, everyone. We finally achieved the compatibility with Cred mobile application, and I'm going to show a quick demo how we can use a V6 library together with Cred. For this demo, I'm going to use a Faber Pi script, which is written on Python above VCX, and this script represents inviter, issuer, and verifier sites. For Cred, I downloaded a mobile application from Google Store, and this application is also available for iOS devices in App Store. So next, I'm going to use a builder net. Here we can see this transaction. Let's ensure that I have builder.net set up on Cred also. Good. So in the left side of my screen, you can see a console where I will start FaberPi, and on the right side, you can see Cred application. Let's start. I'm running FaberPi. It does provisioning connecting to his own agent. I would like to point that this agent should be public available to be able to talk with Cred. Next, it does preparation of schema and credential on the ledger. It may require some time for key generation. And after credential definition is published, connection process is started, and here we can see an invitation. We have to do some preparation. First, encode this invitation, put to specific format which is described in areas connection HIPE, and convert this view. Seems I did a mistake. Yeah, it's too big. It convert this invite to QR code. Now I'm going to scan this QR code from mobile app. So on the screen, we can see a pop-up which tells us about received invitation. Let's accept it and wait for some time. Connection protocol is going now, and Faber and Cred and Alice exchange messages. Here, Cred site looks completed, and now we are looking at BCX, and here we can read a new line, connection response from Alice is received, but technically connection isn't completed yet. We need to send ping message to be ensured that remote site is available. On Cred in connection section, we see Faber record. Let's see ping and wait for some time for response. Well, ping response message was received, and now connection is established, and we can start issuance. Let's choose the first option. The 6 sent credential offer to Alice, and now we should get an action which tells us that Faber offers us a credential. Let's accept it. Credential issuance protocol started, and Alice and Faber do exchange messages. Well, it's completed. Let's go to wallet and look. We have a credential. We can use the credential for proof verification. And let's ask proof. Choose the second option. Proof request was sent. Here we can see a pop-up. Let's accept this proof and present and create a presentation. Look at Faber. Yeah, here we can see new rows. The proof was received and successfully verified. So that's it. Thank you.
Okay, I believe that's all, Richard. I hear. Can you hear us, Richard?
Sorry, my Zoom paused, but I can hear you now. So the video, sorry, it paused at the very end of the video, but the video finished, right?
Yes.
So I had a question for Artem. Thank you for that. Is that using standard Aries interop, or did we have to do patches on Cred or on the libvcx side?
I had to do some patches, but two of them are still acceptable for Aries interop first version. One of them, I had to update the Python script to manually send a ping message to Cred, but according to connection protocols, Cred have to do it yourself without asking from outside. That's, I think, a key point that's different from Aries interop.
Excellent. Thank you for that. And I want to highlight the good collaboration we had with the Cred team. We identified some challenges in how we are interpreting the RFC, both on the Indy side as well as on the Cred side. And it was really nice to be able to work closely with the team at Cred to make sure we could have real world interoperability. So with that, we're out of time. Thank you, Artem, for that demo, and thank you everybody who watched the video. Of course, if you've found this on the Evernym YouTube channel, you can find our previous videos where we talk about rich schemas and Aries interop. That's on the playlist for our contributions to Hyperledger, Indy, and Sovrin. Well, Hyperledger and Sovrin, Indy, Aries, Ursa, and Sovrin. Also, you can find us at chat.hyperledger.org, where we hang out and have lots of conversations with related to the project. So with that, let us know if you have any questions, and we look forward to working with you.